Hello everyone. You're welcome to this episode of Mathematics Tutorials brought to you by Masker Mathematics Tutorials. My name is Eric. Now, in this video, we're going to solve this problem that was posted on Facebook. All right, now the question says that a raised to the power a plus b is equal to b, and b raised to the power a plus b is equal to a squared b. Solve for all possible values of a comma b. All right, so let's put here a solution. We are going to, let's bring the question down once again. So we have a, so let's write it properly. So that is a raised to the power a plus b. This is equal to b. And then we have b raised to the power a plus b. This is equal to a squared times b. That is a squared b. All right. So now this is what we have. And then we're going to uh, apply the rules of indices or exponents in solving this question. All right. So now let's write one more step. What we're going to do here is that we are going to multiply this equation together, since our aim is to find the values of a and b, a comma b. So we are going to multiply each side of the equation, the left hand side of the equation together, and then the right hand side of the equation also together. So now this is what we're going to do. So we shall have a raised to the power a plus b. Now multiplying b raised to the power a plus b. This is equal to, on the right hand side, we shall have b multiplying a squared b. So b multiplying a squared times b. So this is what we have. All right, so now let's come to the top and perform that operation. So let's rule a line here. Now, which rule are we going to employ to solve this? Now, remember that we have this rule that says that if you have a raised to the power m times a raised to the power times b raised to the power m, this is equal to ab raised to the power m. That is different bases, but the exponents are the same. Multiply the bases and then raise to the power the exponent. So that is what we have done over there. So that rule is what you're going to apply here. So rewriting this, we shall have, let's come to this side, we shall have a multiplying b, that is a times b, now raised to the power a plus b. All right, so applying that rule, that is what we have. And then this will be equal to, the other part is multiplying b times a squared b will be b squared. That will give us b squared, and then what? Or a squared b squared. So it will give us a squared b squared. Now, you can see that we can still apply this rule over here, which is a times b raised to the power m. So if that is the case, then we can rewrite a squared b squared as a times b all squared. So we can do that. All right. All right. Now, if we can do that, then what we're going to do is, looking at the left-hand side of the equation and the right-hand side of the equation, we see that the bases are the same. So we shall equate the exponents, that is a plus b. So we shall have a plus b. This is equal to 2. So we have a plus b is equal to 2. We can see that. Now, we are using the rule a raised to the power m times a raised to the power n is equal to a raised to the power. So when the bases are equal, we equate the exponent. That is a raised to the power m is equal to a raised to the power n. Then it implies that m is equal to n. So that is what we have just applied here. The bases are equal, so we equate the exponents. Now from here, we can see that if we are saying that a plus b is equal to 2, then we can say that we can find b, or we can find a. We can say that b is equal to, or we can say a is equal to 2 minus b. We can say that. So that is a. Now, if that is the case, then remember that we have been told that a raised to the power a plus, and then what is our b? We can also write our b. So our b is also equal to um, 2 minus a. So that is it. So now we come here, we can see that the first equation says that a raised to the power a plus b is equal to b. Remember, we are saying a plus b is equal to 2. So if we use this equation, it means that when we substitute a plus b to 2, so we shall have a squared is equal to b. What is our b? We have defined b to be equal to 2 minus a. So in this case, we shall have a squared plus a minus these 2, this is equal to 0. Now this gives us a quadratic equation. All right, so a quadratic equation factors two numbers, you add or subtract, you get 1. You multiply, you get negative 2. What are the two numbers? So we shall have the numbers to be, that is negative 1, that is a minus 1, and then a plus 2. All right, this is equal to 0. So we use the zero property or the zero factor property, as we know in solving quadratic equations. So it follows that we have a to be equal to 1, or we have a to be equal to negative 2. Now, if we have got two values of a, which is 1 and negative 2, then it follows that we shall have two values also for b. All right. So let's substitute the values of a equal to 1 into the equation to find b, and then another is when a is equal to negative 2 to find the second value of what? B. All right. So now let's find space and do that. Where are we going to do that? We can do that here since we have already used the question is still written here. So let's make use of this space that we have over here. All right. So now this is what we're going to do. So now let's find the value of b. Now to find b, we say that for b we can simply write for b. So um, for b, a is equal to 1. Okay. B will be equal to what? B will be equal to, substitute the value of a is equal to 1. So we say b is equal to 2 minus a. So b is equal to 2 minus the value of a. So b is equal to 2 minus a. So b will be equal to 2 minus 1. And then b will be equal to 1. Or we shall come here and say that b will be equal to, when a is equal to negative 2. So we shall have b is equal to 2 minus a. So b is equal to 2 minus negative 2. Remember that a is negative 2. So we shall have b to be equal to 2 plus 2. And so we shall have b to be equal to 4. All right, so it follows that when a is equal to 1, and when a is equal to 1, so for b is equal to a is equal to 1, and then a is equal to negative 2. So we shall substitute these two conditions. All right, so now what we are going to do is that when a is equal to 1, b is equal to 1. And when a is equal to negative 2, b is equal to 4. So the set of values that we have for a comma b, which we are finding, is that we have the values a, that is when a is equal to 1, b is, or when a is equal to 1, yes, b is equal to 1. So b is equal to 1. And then when a is equal to negative 2, b is equal to 4. So when a is equal to negative 2, b is equal to 4. So this is what we have. So these are the set of values that we have that the set of all the possible values that we have for A, comma B. So we have A, which is we have the first values, the set of values, which is 1, 1. That means when A is equal to 1, B is equal to 1. And then also when when A is equal to negative 4, B is equal to 4. On that note, thank you very much for watching. I hope you do understand. Now, if you want to find out if the answers are correct, you can take the values of A and B to be 1, 1 and substitute it here. Now, when A is equal to 1 and B is equal to 1, 1 plus 1 is equal to 1 plus 1 will give you 2. And when A is equal to 1, so 1 squared will give you B, which is 1, and it is true. And then come here and then substitute also the value of 1 and B is, when B is 1, also put 1 here and put 1 here and put 1 here and see if it works, it checks. So this is B raised to the power 1. B is equal to 1. So 1 plus 1 will give you 2. And then B is also 1. 1 squared will be equal to A squared is what? 1 squared, which is 1. 1 times B is 1, so it's 1. So 1 squared will give you 1, which is equal to 1, and it checks. And then also let's try negative 2 and 4. So let's say that when A is negative 2 and then B is equal to 4. So negative 2 and 4, and remember A will be negative 2. So negative 2 raised to the power 4, negative 2 plus 4 will give us negative 2. And so negative 2 squared will give us positive 4. All right. And then this is equal to B is 4. And so 4 is equal to 4. It checks. And then also let's use let's use 4 now for B. So now we put A here to be equal to negative 2. So and then this is negative 2 plus B is 4, which is equal to what? So now this is equal to negative 2. This is also negative 2. So 4 minus 2, this is negative 2. That's to be 2 squared. So negative 2 squared will give us 4. 4 is equal to 4. And then when we say that A is also equal to negative 2, then what are we going to have? So A being equal to negative 2, so we shall have negative 2 raised to the power negative 2 plus 4 is equal to what? Will it give us this? So this will give us negative 2 squared, which will give us 4. And then on the right hand side, we have A squared, which is equal to negative 2 squared times B. B is equal to 4. So B is equal to 4. So negative 2 squared is 4. 4 times 4 will give us 16. Now, when we come here also, and then we put A to be equal to negative 2, we shall have B, which is B is 4. So we shall have 4 raised to the power negative 2 plus B is 4. And that will give us